Okay, welcome. So I will show you how to prepare a cumulative distribution function and then calculate the performance of that distribution and compare it by using a Kolmogorov-Smirnov test or KS test. So let me share the screen. Okay, now it's going well. So we are using R. So for these purposes, we need to install library ggplot2 and fit distribution plus for fitting the distribution and for data visualization. So for this library, install it first and then go to your working directory. So this is my working directory, set working directory, which is your folder where you put your data, CSV data. So in this case, we are using CSV data. We are reading CSV file. So my CSV file is quite lengthy name. So don't do like this. It's quite long name. So, but actually this is our data set. This is our data. We have uh, a time series of daily time series between two of these station data. So actually I want to compare between station data and grid point of chip dataset and this station data with closest chip's grid point of chip dataset. I want to compare and assess the performance of chip dataset is if the chip's data can simulate the data properly. So the dataset is a yearly time series for 1981 to 2018. So let's compare. Set the working directory with the data and then so in this case I want to compare between column 6 and 7. Column 6 and 7 is this station and grid point number 7. So after that we calculate the empirical CDF for each of this dataset by using the CDF function, and then we calculate the sequence of value within the range of the data to evaluate the CDF range of value, which is the mean and maximum value of this historical data and original dataset, so that we can get the minimum and maximum value. And then we calculate the CDF by using this function. Okay, by using this line of code, very easy. And then we plot the CDF by using ggplot2. So we get our data frame of original and historical dataset, and then we have two geom line for historical and another one for original GCM, but actually this is for chips dataset actually. And then make a label for X and Y. X axis is rainfall, Y axis is cumulative probability, and then the color of the label and the legend of the label. So I will use blue and black for blue for station data and black line for chip dataset. So let's plot this, and then you get your CDF. Very easy. So x-axis is rainfall, y-axis is cumulative probability from 0 to 1. So you can see the relationship between station data and chips dataset here. And then to calculate objectively the relationship between this distribution, you can use Kolmogorov-Smirnov test. So you can use ks.test function, and then you print the result. So you get the result here. As you can see, this is the result. So if you don't know how to interpret the result, you can just use ChatGPT to describe this result. Let's describe this result. Example here. Okay, now it's okay. So now it's telling you what is the result from R just now. We just copy this one. What is the meaning of this result? So it's tell you what is that statistic means, what is the value of p-value, and the most important one, just go to summary. It will tell you that the KS test strongly suggests that there is significant difference between original dataset and his historical dataset. So that means that this distribution just now is actually different. This different. It's not similar. based on Kolmogorov-Smirnov test. So that's mean chip's dataset. Some properties of chip dataset cannot simulate the station data properly. So there's a discrepancy there. It might be the chip's dataset cannot simulate the extreme rainfall properly in tropical country. Usually the case, and usually the case for that is usually the case for a graded dataset. But it still can be justified because the of graded dataset is still there. You can still justify that uh, the failure is usually because of the graded data fail to capture the extreme rainfall. But still, this is for daily data. You can compare for monthly data also. If it can capture the monthly data properly, then you can just show the monthly data performance. So if usually the monthly data will show you the better result. Okay, I think that's all.